welcome to my channel. Max 2A Chapter 2 Exercise 2B. In the previous video, I have solved the first Roman entire problems and second Roman first question. Now let's proceed with the next questions. Roman 2 third question. Given that we should find the number of 15 roots of unity which are also the 25th roots of unity. So for this, normally first write what is the HCF of 15 and 25. Yes, it's exactly 5. Therefore, the number of common roots is 5. Common roots why I am writing? Because 15 roots of unity are also the 25th roots of unity. So it means they are common root. Therefore, the number of common roots is 5. So this is the answer. Fourth question. You are given that cube root of unity is 1 omega and omega square. As the cube roots of unity is this, we know that omega cube is equals to 1 and 1 plus omega square is equals to 0. Okay. Now we have to find the roots of this equation. So to find the roots of this equation, first what I will do is consider the given equation, that is x minus 1 whole cube plus 8 is equals to 0. Now x minus 1 whole cube, this 8 I am sending to the other side, so I will get it as minus 8. Now minus 8 can be written as minus 2 whole cube. Now I am multiplying 1 here. Why? Let us see. X minus 1 whole cube is equals to minus 2 whole cube 1 to the power 1 by 3. Because 1 to the power 1 by 3 is nothing but what? Cube root of unity. So we can substitute there these 1 omega and omega square. That's the reason I'm writing. Now what I'll do is I have raised here to the power 1 by 3 so that I can substitute 1 omega and omega square here, and these cubes can be cancelled. Both sides. Okay, understood. Here what I will raise to the power 1 by 3. So what I will get? X minus 1, which is equals to minus 2 cube roots of unity, substitute. Now x will be equals to 1 minus 2 1 omega square is to 1 minus 2 comma 1 minus 2 omega comma 1 minus 2 omega square. Therefore x is equals to minus 1 minus 2 omega and 1 minus 2 omega square. This is the answer. We have to find in the fifth question the product of the values of 1 plus I to the power 4 by 5. So for this, let x be 1 plus I to the power 4 by 5. Therefore z will be equals to 1 plus I. From this, P, the point is 1 comma 1, which lies on in the first quadrant. Therefore the angle made is here is positive acute angle. Therefore theta is equals to tan inverse y by x, which is equals to tan inverse 1 by 1. Theta is equals to tan inverse 1, tan theta is equals to 1. Therefore theta is equals to pi by 4, a positive acute angle. And in the similar way, modulus of z, that is r, equals to root of 1 square plus 1 square, which will be equals to 1 plus 1 root 2. Now I will write the modulus amplitude form, that is z is equals to r cos theta plus I sin theta. Substituting r and theta value, we get this. We have to find 1 plus I to the power 4 by 5. So first I will raise it to the power 4, then I will raise it to the power 1 by 5. So I have raised it to the power 4, after which I will get it as root 2 to the power 4 is nothing but 4 times root 2, which will be equals to 2 into 2, 4. Is it right? So I am substituting 4 over here, after which I will bring this power here, so I will get it as cos 4 pi by 4 and plus I sin 4 pi by 4, where I can cancel 4 and 4. The final answer I'll get it as 1 plus I to the power 4. When I raise it to the power 4, 4 cos pi plus I sin pi. Okay, now to this I will raise this to power 1 by 5. Okay, raising it to the power, I will get 1 plus I to the power 4 by 5, which is equals to 4 to the power 1 by 5 cos 2k pi plus pi plus I sin 2k pi plus pi to the power 1 by 5. Right? Now I will get this as x. This is the value of x I have considered in the beginning of the problem, isn't it? So x will be equals to 4 to the power 1 by 5 cos, when I bring this power 1 by 5 here, that is, I will multiply, I will get this 2k pi plus pi by 5 plus I sin, right? Now if I have raised to the power 1 by 5, I should get 5 values. Okay, I will substitute from 0 to 5 values. That will be 0, 1, 2, 3 and 4. So for these 4 values, I will find the value of x. X will be equals to 4 to the power 1 by 5 and k equals to 0 cos pi by 5 plus I sin pi by 5, which will be equals to 6. 4 to the power 1 by 5, 6 pi by 5. In the similar way, when I consider k as 1, I will get x is equals to 4 to the power 1 by 5 cos 3 pi by 5 plus I sin 3 pi by 5, which will be equals to, for sure, 4 to the power 1 by 5 is 3 pi by 5. When k is equals to 2, x will be equals to 4 to the power 1 by 5 cos 5 pi by 5, that I sin 5 pi by 5, which will be equals to 6 of 5 pi by 5. In the similar way, when x is equals to 3, 4 to the power 1 by 5 cos 7 pi by 5 plus I sin 7 pi by 5, which will be equals to 4 to the power 1 by 5 is 7 pi by 5. And when x is equals to 4, finally we will get cos 9 pi by 5 plus I sin 9 pi by 5, which will be 4 to the power 1 by 5 is 9 pi by 5. Therefore, x is equals to 4 to the power 1 by 5 is pi by 5, 4 to the power 1 by 5 is 3 pi by 5, 4 to the power 1 by 5 is 5 pi by 5, 4 to the power 1 by 5 is 7 pi by 5, 4 to the power 1 by 5 is 9 pi by 5. Now we have to find the product, right? Product of the values of x, right? It is given to find. So we will multiply all these products. If we multiply, what we will get? 4 1 by 5. This is 5 by 5 into, right? Now I can take 4 to the power 1 by 5 common. Taking 4 to the power 1 by 5 common, I'll get 6 pi by 5 plus 6 t pi by 5. Sorry, into 6 5 pi by 5, 6 7 pi by 5, 6 9 pi by 5. Okay, this 4 to the power 1 by 5 is 5 times. 1 2 3 4 to 5. Therefore you will get whole to the power 5 here. 5 gets cancelled, so you will get 4. This will be nothing but I am again taking 6 outside only. So if I take 6 outside, I'll get 4 6 pi by 5 plus 6 a plus b, 6 of a plus 6 a into b, 6 of a plus b, right? So 5 by pi by 5 plus 3 pi by 5 plus 5 pi by 5 plus 7 pi by 5 plus 9 pi by 5, which will be equals to 4. If I add all this, I'll get 25 pi by 5, which will be equals to 4 6 5 pi. 6 5 pi is nothing but cos 5 pi plus I sin 5 pi, which will be equals to 4 into cos 5 pi is minus 1 plus 0, so minus 4 will be the. So I have multiplied all these things to get the product of the values of x. Multiplying 4 by 1 to the power 5 can be taken common, and it is 5 times, so I'll get 4 to the power 1 by 5 whole to the power 5, which will be equals to 4 only. Then I'm having 6 pi by 5, all these terms, in which I'm taking 6 again common, after which I'll be left with pi by 5 plus 3 pi by 5 plus 5 pi by 5 plus 7 pi by 5 and 9 pi by 5. Adding all these terms, I'll get 25 pi by 5. 4 6 25 by 5, which is equals to 4 6 5 pi. Now this is 5 pi can be written as cos 5 pi plus I sin 5 pi, which is nothing but minus 4 is the value. So the product of the values of x we got is minus 4. So this is the final answer. Sixth question. Given z square plus z plus 1 is equals to 1, and you have to prove that this LHS is equals to 12. So for this, first consider the given condition, that is z square plus z plus 1. Now z square plus 1 in the left hand side and send this z term to the right hand side. So you'll get it as z square plus 1 equals to minus z. Now square. If you square, you will get it as z to the power 4 plus 1 plus 2z square equals to z square, which will be equals to z to the power 4 plus 1 plus 2z square minus z square equals to z to the power 4 plus z square plus 1. So from the given condition, we have obtained this condition, which we can use to solve the problem. Consider LHS. This is the LHS. Now I will expand each and every term, that is a plus b whole square formula I will use. So expanding, I will get z square plus 1 by z square plus, here you will get 2z into 1 by z. Z gets cancelled, will be left with 2, right? That is 2xy. So z square plus 1 by z square plus 2 plus z to the power 4 plus 1 by z to the power 4 plus 2 plus z to the power 6 plus 1 by z to the power 6 plus 2 plus z to the power 8 plus 1 by z to the power 8 plus 2 plus z to the power 10 plus 1 by z to the power 10 plus 2 plus z to the power 12 plus 1 by z to the power 12 plus 2 you will get, isn't it? Here how we got z to the power 4? Z square whole square z to the power 4. How we got z to the power 6? Z cube plus z cube whole square, that is z to the power 6, z to the power 4 whole square is z to the power 8, z to the power 5 whole square is z to the power 10, z to the power 6 whole square is z to the power 12. In simple way we are expanding this. Now from this you have to add these 2's here, so you will get 12. 2, 4, 6, 8, 10, 12. So you will get 12 here. Plus we will take these terms z square, z to the power 4, z to the power 6, z to the power 8, z to the power 10, z to the power 12. So I am combining one term as z square, z to the power 4 plus z to the power 6. Okay. And one more z to the power 8 plus z to the power 10 plus z to the power 12. I'll say why I am writing in this way. Plus now this 1 by z square, 1 by z to the power 4, 1 by z to the power 6. And then 1 by z to the power 8, 1 by z to the power 10, 1 by z to the power 12. Now 12 as it is you write. Then from this I am taking z square outside, that is common. After taking z square I will be left with 1 plus z square into z square, z to the power 4, z cube, z to the power 4. Bases are same, powers can be added in multiplication, right? So 4 plus 2, 6, so z to the power 6, that is z square into z to the power 4. So this is nothing but the condition we have got here, which we can substitute as 0. That's the reason we are combining here these three terms, these three terms, these three terms and these three terms, so that if we take something common in this, we will get a condition which we have got with the given condition, and we can substitute 0 over there, right? So now in the similar way for this condition also I am going to take z to the power 8 common, so left with 1 plus z square plus z to the power 4, right? See, the 8 plus 2 10, 8 plus 4 12, right? Now for this term I will take 1 by z to the power 6 common, so I will be left with z to the power 4 plus z square plus 1, because when we divide, so if suppose it is z to the power 4 by z to the power 6, we will be left with what? 1 by z square, that is nothing but this term only, right? So this term we can substitute at z to the power 4 by z to the power 6. Similarly this term can be substituted as z square to the power z by 6 divided by z to the power 6. So we'll get 1 by z4 if we cancel in a similar way. That's the reason we are taking 1 by z to the power 6 common, and we'll get this condition. Similar way 1 by z to the power 12 left with z to the power 4, z square and 1. Now this and this can be substituted as 0. If I substitute, what will get? 12 plus z square into 0 plus z to the power 8 into 0 plus 1 by z to the power 6 into 0 plus 1 by z to the power 12 into 0, right? Which will be equals to 12. So this is what is the RHS, hence proved. Though this is a big problem, but a simple problem only. Thanks for watching the video. Do like, share, comment and subscribe. Don't forget to hit the bell icon.